Okay, I'm going to go over the parent function review for you. Okay, number one, the name is a constant function. So the equation would be f of x equals c, a constant. That constant is a number. Y equals 2, y equals negative 10. So in this case, I'm just going to y equals 3. So I'm going to go up 1, 2, 3. And I'm just going to make a horizontal line going to the left and right. This is what we call a constant. Make sure you put your arrows. So the domain, again, is your x, range is your y. So we're going from negative infinity to positive infinity. Remember, all infinities have parentheses, and the range here is just whatever the constant is. So here, this would be up 3, so it would be bracket 3. Next one, absolute value. Okay, the equation is your f of x equals the absolute values of x. Okay, if you remember your parent function table, x, y, negative 3, negative 2, negative 1, 0, 1, 2. You can go 3, you can keep going. When you take the absolute value, you're talking about distance on a number line. So how many units am I from 0? So the absolute value of negative 3, 3. The absolute value of negative 2, 2. Absolute value of negative 1, 1. 0, 1, 2, and 3. So for your parent function, you're starting at your HK. Y equals A times the absolute value of x minus h plus k. So we're starting at 0, 0. Well, that's what this value is right here. You would go right 1, up 1. Back to your origin. Right 2, up 2. Back to your origin or starting point. Right 1, 2, 3, up 1, 2, 3. Oops, sorry. 1, 2, 3. And then it's just a reflection, and that's how we get going to the left. Left 1, up 1. Left 2, up 2. Left 3, up 3. So this would be your absolute value. It looks like a V. The domain here is negative infinity to positive infinity. Your range, your lowest value here for your y is 0, so bracket 0, and it heads off to positive infinity. And I should have been going in order. That was number 3. Sorry about that. So let's look at number 2, which is the linear function. Y equals mx plus b. So f of x equals x. So we're starting at the origin, 0, 0. Slope is 1, up 1 over 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 1. And then down 1, left 1, down 1, left 1, down 1, left, down 1, left, down 1, left, down 1, left, down 1, left. So there's your linear function. Sorry, I don't have a ruler. Okay, your domain is negative infinity to infinity. I know students always say, can I put all real numbers? We want you to write it in interval notation. So negative infinity to infinity is how we want you to write it, not saying all real numbers. Okay, so again, I did number 3, which was the absolute value. Now we're going to go to the quadratic. That is f of x equals your x squared. Okay, again, you've learned these. Okay, if we need to make a parent function table, you can. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Negative 3 squared, 9. Negative 2 squared, 4. Negative 1 squared, 1. 0 squared, 0. 1, 4, and 9. So we're starting at 0, 0. Right 1, up 1. Back to our starting point, 0, 0. Right 2, up 1, 2, 3, 4. If I would go over 3, I'd be off my graph. It's reflection again. Left 1, up 1. Left 2, up 4. Okay, quadratic is your U. Domain, negative infinity to infinity. Range, your lowest is bracket 0 to positive infinity. Alright, next one, square root. That is your f of x equals the square root of x. So here, we want numbers, and this is why we've been talking about this underneath the radical. We want numbers greater than or equal to 0 because we don't want negatives because that means it's imaginary. So we got to think about this. I can take the square root of 0. I can take the square root of 1, 4, 9. So the square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. So we're going to start at 0, 0. Right 1, up 1. Back to 0, 0, your starting point. Right 1, 2, 3, 4, up 2. I can't go over 9, so we're just going to leave it like this. So our domain, x, is starting at 0, bracket 0, and it heads off to positive infinity. Same thing with the range. The lowest y value is 0, bracket 0, and your y values are just going to get bigger, so they're heading to positive infinity. All right, next one, the cubic. F of x equals x cubed. So if I want to do a parent function table here, negative 2, negative 1, 0, 1, 2. Negative 2 cubed is negative 8. Negative 1 cubed, negative 1. 0 cubed, 0. 1 cubed, 1. 2 cubed, 8. So again, all these are starting at the origin because they're their parent functions. Yes, we have transformations where we move them left, right, up, and down as well. So starting at 0, 0, I'm going to go right 1, up 1. Back to my starting point, right 2, 1, 2, 3, 4, 5, 6, 7, 8. It's off my graph. Then I go left 1, down 1, left 2, down 8, which again is off my graph. So this is what my cubic looks like, x cubed. Domain again is negative infinity to positive infinity, and same thing with the range, negative infinity to positive infinity. So these are the ones that you have definitely learned in Algebra 2. Getting to where the new stuff, okay, your reciprocal function, that is going to be f of x equals 1 divided by x. Well, again, we've been talking about fractions and domains. We don't want x to equal 0. The reason why is because there's an asymptote there. Okay, so we're going to be having an asymptote at x equals 0, and then we're going to have a horizontal at y equals 0. And again, we're going to get more into detail to that later, but you just have to know that whatever your hk is, so y equals a times, 1 over x minus h plus k. You pull off your hk, that's going to give you your vertical and your horizontal asymptote. So now, if I make a table, let's see, let's do negative 3, negative 2, negative 1. You'll see why 0 doesn't work here in a minute. Okay, so if I plug in negative 3, that's going to give me negative 1/3. Plug in negative 2, negative 1/2, negative 1, negative 1. Plug in 0, it's undefined. It doesn't work because of vertical asymptote. Then 1, 1/2, and then 1/3. So here, when I go to graph, I'm going to go left 1, down 1. Left 2, down 1/2. Left 3, down 1/3. So what's happening is your graph is getting closer and closer to your vertical and horizontal asymptotes. Then when I come over to the other side, up 1 over 1, right 1 over 1, right 2, up 1/2, right 3, up 1/3, and it's doing the exact same thing here. So this is the parent function of a reciprocal. You're graphing in 2 locations. So my domain is going from negative infinity and it approaches 0. So negative infinity approaches 0 with the parentheses, union, and then it picks up over here, approaching 0, and it heads off to positive infinity. Range, negative infinity approaches 0. Union, and then again it picks up from 0, heads off to positive infinity. So that is called a reciprocal function. Then we have the new one, the greatest integer, that we're going to be going over here in the next couple days. F of x equals the greatest integer. Okay, so we've got to think about integers on a number line real quick. Let's say this is 0, this is 1. Okay. We're going to start at 0 because 0 is an integer. All these values between 0 and 1, since they have not hit, that's going to be an open circle, since they have not hit 1 yet, they're all going to round down to the integer 0. So, starting at 0, 0, and an open circle at 1, all the values, those decimals and fractions, in between 0 and 1 is all going to round down to 0. Now, the greatest integer you can think of and hear it as a step function. So now I'm going to step up 1. Close that circle. Go to the right, open circle. All the values between 1 and 2 are now going to round down to the integer 1. So everything's going to the left. It's rounding down. Step up, close circle, over 1, up, an open circle. So now from the integer 2 to 3, all those values are going to round down to 2 because it hasn't hit 3 yet. And so this is just going to continue going up. Okay. Now we go the other way. Since this is already a closed circle, we're going to open that circle and go to the left. Close. So now when you're going negative, okay, on the negative side, all the values between -1 and 0, well, they haven't hit the integer 0 yet. So they're all going to round down to -1. When I take a step down, all the values between -1 and -2, they're all going to round down to -2. Because they haven't hit -1 yet. And so this is just going to continue a step function. So it keeps going down, open, closed, open, closed, open, closed. So I should have gone this way here as well. Closed, open, closed, open, closed, open. I should not have drawn that arrow because you don't want to connect these at all. Okay? Do not connect these with a line on either side. It is a step function. Okay? It is a step function. We're not going to talk about anything about domain and range on that. Okay? So now, if we turn to the back, okay, we're going to look at number 10 real quick. Okay, I'm not going to do all these, but now that you've seen some, this is the reciprocal function. Okay, so it asks for what is the parent function? 1 over x. So we're going to pull the HK off. The HK has never changed, even into pre-calc. Your HK here is 1 comma -2. Now we're not going to go put a point there. We're going to go put like a little T. So 1 down to -2. That's going to help create your vertical asymptote, which is at x equals 1. So x equals 1. And then your horizontal at y equals -2. So now, okay, since this is a positive 1 divided by x minus 2, you know your graph is going to be in this part and this part over here. So if you go back and think about your parent function now, table, -3, -2, -1, 0, 1, 2, 3. Okay, -3 gave us -1/3 in the parent function, y equals 1 over x. Then that was -1/2. Then -1, undefined there. Well, that's where that vertical asymptote and horizontal is. Then 1, then 1/2, 1/3. So now we're not starting here, we're starting here. Okay, we moved using the transformations, 1 down -2. So starting here, now I can use this table. So right 1, up 1. Back to the new starting point. Right 2, up 1/2. Back to my new starting point. Right 3, up 1/3. And there's my graph. Now I go on the other side. Starting my new starting point, left 1, down 1. New starting point, left 2, down 1/2. oops, I'm right here, sorry. Back to our new starting point, left 3, down a third. So again, it's graphed in quadrants 1 and 3. Of course, it kind of moved now. This is your old coordinate plane. This is your new one. So here, oops, and I'm sorry, I put that in the wrong spot. That should have been y equals negative 2. So your domain's going from negative infinity to 1. So negative infinity to 1, union picks back up over here at 1, and it heads off to positive infinity. Your range is going from negative infinity to this horizontal at negative 2. Union, it picks back up negative 2, and it heads off to positive infinity. So we'll just kind of briefly talk about this here. Your starting location, opposite sign, keep that sign, HK. So now you would be starting at negative 4, negative 3. 1, 2, 3, 4, 1, 2, 3. That's your square root function. So now think about your square root table again. 0, 1, 4, 9. Square root of 0, 0. Square root of 1, 1. Square root of 4, 2. Square root of 9, 3. So starting at this new location, that's why we moved it. Now we can use this new table. That's your new 0, 0. Right 1, up 1. Back to my new 0, 0. Right 1, 2, 3, 4, up 2. Back to my new starting location. Right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3. And there's my square root. Domain, this is your 1, 2, 3, negative 4. So bracket negative 4 heads off to infinity. This is down 1, 2, negative 3. So negative 3 to positive infinity. Now, looking at this greatest integer. Okay, this is your greatest integer. Your HK is 2, 3. So now we're going to go over 1, 2, 3. Oops, sorry. 1, 2, up 1, 2, 3. That's where your new closed circle is going to be. Your open circle is going to be right here. So all the values in between 2 and 3 is going to round down. Now, we want you to circle your starting point, your new starting point. Okay, because that's what we're going to be looking for on your quizzes and tests. Where are you starting? And then it's just up, closed, open, closed, open, closed, open, closed, open, and then you go the other way. Open, closed, open, closed, open, closed, open, closed. And I sound like a broken record, I know. Open, closed, open, closed, open, closed, open, closed. So, yes, you should see all these are closed circles and these are all open circles, but do not connect them with the line. Okay? When you see y equals 4, that's your constant. So, 1, 2, 3, 4. I'll just draw a little y equals 4. Okay, looking at this is your cubic, so you take off your HK, negative 2, 3. You should be able to graph those again. Absolute value, 1, 2, but you have to be careful. Now you have a reflection, so instead of going up, you're going to go down and you're going to stretch. Okay, this is linear, so you're starting at negative 1, negative 2. That's just your good old slope. Quadratic, 1, 3. You have a reflection, so instead of opening up, you're going to open down, and a stretch of 2. So I just wanted to go through that so you have a better idea of your parent functions.